Hey there, welcome back to another video. Today we're going to talk 480E build strategy for high performance applications where engines are making in excess of 500 horsepower. Alright, so this video is going to feature what I call the 5 fundamentals of transmission building, and then I'm also going to talk in some length about the Jake's Performance recalibration kit, covering what you need to know when working with it, its benefits, its features, because that's what we're going to be reinstalling into this transmission. And then I will cover hard parts, including lube modifications and tips and tricks for setting one of these transmissions up so that you can be successful in your your performance applications. So let's go ahead and get a little closer to the bench and we'll begin. Alright, before we get too much further, let me kind of level set and talk about the application that this transmission is going to be installed into. So it's going to be a late 90s Chevy Silverado GMT 400 truck with a LS53 turbo swapped into it that's making between 500 and 700 horsepower. It's a daily driver, but will go to the track and does go to the track every so often, usually once or twice a month for maybe a handful of passes each time. So we want to build it per that application, and because you can change the amount of horsepower the engine's producing in a turbo setup by plugging in your laptop and hitting a couple of keystrokes, we want to build it based on the overall power potential, not what the everyday walking around power is. So he usually keeps it around 500 horsepower, but on the days he goes to the track, he'll turn the boost up and he'll be producing around 700, maybe even a little north of that. So that's kind of what we want to build this thing for and calibrate it so that he's successful at the track, because that's going to be the more intense and or quote-unquote worst case scenario in terms of what the transmission is going to see during its lifetime. Alright, let's start off with the basics, the blocking and tackling, so to speak, when it comes to building transmissions and what you need to be thinking about and what kind of part selection and decisions you should be making, and we'll frame it up based on what I call the 5 fundamentals of transmission building. So those 5 key areas of focus are going to be as follows: soft parts, electronics, bushings, one-way assemblies, and hydraulics. Okay, if you get all 5 of those right, regardless of what you're doing and what kind of application you're building your transmission for, chances are everything's going to be fine, provided you assemble everything correctly following proper procedure. So first, let's talk soft parts. For these transmissions, TH400s, 480Es, you don't need anything too fancy. Borg-Warner Ray-Bestis high energy friction module with a standard factory steel module is going to be fine, even up to like 800,000-900,000 horsepower. Believe it or not, myself and plenty of other builders have had these transmissions live, survive, and thrive in those kinds of use cases with just those sort of friction and steel modules. You can use choline steels if you want. I typically don't. In fact, the only transmissions that I really like choline or Lindard steels for are the 4L60Es and 700R4s in the 3/4 clutch pack. I mean, that's really it, to be honest. You can certainly, like I said, put them in, spend a little extra money on them, but I don't think you need them. Okay, for bonded pistons, we're going to go with the Seal Performance or Seal Aftermarket Hyper Blue molded piston set. And I've been using them over the course of the last year or so and have had good success with them. If you want to use the National Seal brand, which is the OEM stuff, that's also perfectly fine. I don't yet know if these are truly any better. The price is about the same, give or take a few dollars here and there. So I guess it's whatever's available, to be honest. Okay, we're going to replace both bands. Anytime I go through these transmissions, I never reuse the rear band. I know some shops like to consider that a hard part, but I typically don't. But it's up to you. Use your judgment. But if you're wanting to have a successful build, especially if you're either turning or replacing the rear planet with an otherwise very good used one where the band surface is in very, very, very good condition, then I would recommend you install a new low reverse band. Okay, and same with the coast band. Alright, so other soft parts are in the overhaul kit, which is what you see in the back. So that's just all your basic stuff, gasket seals, O-rings, sealing rings, things of that nature. When it comes to sealing rings for these units, there's 3 different types. You can use the scarf cut Teflon sealing rings for the center support. one-piece solid Teflon rings or the plastic style interlock rings. Any one of those three variants is fine. One is not any better than the other two, so dealer's choice. Early 480Es used to have the large blue solid one-piece Teflon sealing rings for the stator and the pump. They're out of production. I've not seen them in years. I used to use them, but you need a special sizing tool, and like I said, there's really no advantage to them over the interlock style rings that come in all the kits now. So just in case you were wondering. Alright, that is soft parts. Let's talk about electronics. Every single transmission you build that's electromechanically controlled, where you have, solenoids, a wiring harness, or, transmission control module, lead frame, or anything of that similar, like kind, description, nature, or sort, where there's electronic components inside the transmission, electrical components, speed sensors and such, inside or on the transmission, you must always replace that stuff. Okay, that is my opinion. I never reuse electronics. The last thing I want is to have a unit go out the door and then, otherwise work perfectly fine, except there's a transmission problem because of an electronics part failure that was reused. Okay, because the first thing that the customer is going to think is, well, you did a full overhaul, I paid all this money, why didn't you replace that one $20 part or that one $50 part or whatever the case may be? Okay, I mean, that's what I would be thinking. So always replace your electronics. Don't put yourself in a position to fail by, trying to save a few bucks on, a solenoid or a pressure switch manifold assembly, or especially a wiring harness, especially on these transmissions, because they like to fail, leak through the case connector, and, cause limp mode and other issues. Don't put yourself in that position as a builder to have to explain to the customer why you didn't replace something like that, and when you certainly could have. So that's my deal there. I know it sounds like I'm on a soapbox, but I see a lot of times on forums folks trying to save a few bucks here and there to shave costs when they're not considering the cost of the risk, if the risk is realized when you're taking this kind of risk by reusing electronics. It just doesn't make any sense to me. So this transmission has all new solenoids, new electronic pressure control solenoid, GM pressure switch manifold assembly. This is the same part number for all of them, 242-22077. Wiring harness is Rostra. When this transmission came in, it had new shift solenoids, I believe a new EPC. The EPC is different. It's a 92 valve body sitting there, but it's got the later style 9302 EPC. I put a brand new one on anyway. I'm not going to take a chance. Like I said, if you have any doubt at all that electronics are not new, then go ahead and replace them. So, all right. So let's talk about one-way assemblies. So same deal, with the electronics. Always replace your one-way assemblies in these transmissions. The low roller assembly, the overdrive roller assembly, and the intermediate sprag. Or in the TH400s after 1970, they had the intermediate roller clutches. Always replace that stuff. Same deal. Don't absorb unnecessary risk by trying to reuse them. I mean, they wear out just like any other consumable or soft part, and it's in your best interest to spend whatever money. I mean, the two roller assemblies together, I want to say they're about $30 between the two of them, if that. The 34 element sprag is what you should be using on all 480Es regardless of year. These are a little bit more expensive, $75, $80, something along those lines. The Board Warner part number is 6763AM, but if you got like a 91 to 96 or 95 or whenever they changed it, if you have one prior to that, always upgrade, because the direct drum is the same and it'll accept it. I mean, they had the 16 element dog bone style sprag for those earlier units. High performance or really even daily driver, I would just simply upgrade to the later sprag for those early transmissions. Okay, same with TH400s. If you're working with like a 64 to 1970, I believe, you will have the smooth inner race, so you can install 480E, late intermediate sprag there as well. Or you can just retro a 480E direct drum into, a 1971 and up TH400. All right, so let's talk bushings. This transmission came in, none of the bushings were replaced. It was otherwise built for performance, but for whatever reason, the factory bushings were, still in all their respective parts when I tore it apart. And I have a teardown video. It's the same transmission, so it's a 480E failed twice in 1 year or something like that. You can check that out for all the details, but the bottom line is that these transmissions and their ancestor units, the TH400s, are extremely hard on bushings, so do not skimp on that critical part of the build process. Alright, bushings are relatively easy to install, remove and install, provided that you have blind hole puller sets and the right size bushing drivers. If you don't, and you don't have any of that stuff, maybe you're a DIYer trying to take this on yourself, your best bet is to simply take all your parts that take the bushings along with your bushing kits. Just take them to a local transmission shop and have them R&R the bushings for you for maybe a couple $100 or so, and that'll set you up for success. Okay, it's not worth saving or skimping on that amount of money when it comes to all the time it takes to rebuild one of these, especially if you haven't done it before. Alright, that's my deal with bushings. The only one other thing I'll mention is for 480Es 2004 and up. The extension housing bushing for the two-wheel drive units changed. Okay, it got wider on the outer diameter. So this is an SAP or Sealed Aftermarket Products bushing. Durabond also makes one. I believe Tri-Components and Clevite make them too. So you can buy them wherever transmission parts are sold, but just know that that particular bushing will not come in your overall bushing kit. You'll need to purchase it separately if you're working with a 2004 480E or up. Okay, 2003 and back, the extension housing bushing is included in the bushing kit. Alright, last, let's talk about hydraulics. Okay, it is so fundamental to address the hydraulics in these units. I can't even begin to tell you how critically important it is not to skip that part of the build process. Okay, that's got to be integral to your strategy if you want to be successful. So when we talk hydraulics, what we're really talking about here is valve body and pump, specifically the stator support. So every transmission that I build where I can, I test the valve body and I test the pump if there's valving in the pump for sealing integrity for all of my bores that have working valves, bore plugs, or end plugs. Anywhere where sealing integrity is going to be a factor, I test. And if the test fails in any one individual working valve or bore or whatever, I remediate it either with an aftermarket part, or and it could be a drop-in valve or a drop-in bore plug, slightly oversized, or I'll chuck it up on the reaming fixture and ream the valve so that I can install either a Transgo or Sonic's oversized valve in that location if one happens to be made for it. If not, I have to replace the valve body. So one of the things that you always want to make sure you install in 480s and TH400s is a new boost valve. Okay, valve and sleeve will come in the kit, whether it be a Transgo or a Sonic's. You can buy them individually, or in the case of Transgo, they will provide them in their shift kits for you. I think Superior Technologies does as well. But the one I always install is the Sonic's 34200-01K. Okay, this is the part number that has the O-ring boost valve as well as the end plug, so that you can seal both ends of that boost and pressure regulator valve circuit in the pump cover. Okay, don't skimp on this, don't skip this. 480Es and TH400s, the Sonic's makes one for a TH400 as well, they are notorious for high line pressure. Okay, high line pressure is usually the result of the factory boost valve and sleeve excessively wearing with respect to each other, and the valve getting cocked sideways slightly in the sleeve, getting stuck in the wide open position. And when you have that, your line pressure is going to go through the roof, all your shifts are going to just be back-breakingly harsh, and you're going to start breaking stuff if you don't immediately fix it. So if you have the trains all apart on the teardown bench like this, do not reuse the boost valve. Put a new one in. So like I said, it doesn't matter if you want to use excuse me, the Transgo valve or the Sonic's valve or the Superior Tech valve or some other valve. As long as it's a good valve and it's brand new, go ahead and install it. It'll have a valve and a sleeve. And sometimes it'll come with a spring as well. So Sonic's, I think, makes a 10% or 5% or 10% spring Basically what that means is it gives you a linear rise all across the engine's RPM band or curve of 5 or 10% increase in line pressure. So it's always good to have that, especially in a performance application. Now you may opt for different springs that produce more pressure. It all depends on what you're doing. Okay, it's it's up to you, and based on what the application calls for. This particular transmission, the valve and sleeve was reused, though I did not see any signs of excessive line pressure. It was, kind of an accident waiting to happen, because upon inspection of the valve and sleeve, I mean, you can visually see that they're both pretty worn out. So, all right. So the other things that you want to keep in mind with these transmissions they're notorious for in the valve body is worn actuator feed limit valves and worn torque converter clutch regulator valves. Okay, I installed a Sonex TCC valve in here. We tested it. It was worn. It had either the factory valve or a Jake's Performance valve. I'm not sure. This whole transmission had a lot of Jake's Performance parts installed. It had the calibration kit, the wear plate, which I'll talk about in a minute, and the, I believe, his Stage 2 master overhaul kit. So, like I said, I don't know who built the transmission. I have no idea, and even if I did, I don't know that I would reveal, the name. It's not something I like to do. I don't like to put other builders on blast. I do like to point out things that could have been done differently, as well as things that were done well. And this transmission had a combination of both of those things. I mean, the builder did some things very well with part selection. He had a billet input shaft installed, a billet forward hub. He set up the direct clutch perfectly, but he did not replace any of the bushings. Some of the electronics were not replaced. The band was not replaced. Some bad parts, or parts that shouldn't have been reinstalled, were reinstalled, or at least they appear to have been reinstalled. So, like I said, I like to try to be fair and balanced in my critiques of other builders' works, and whenever I can, I avoid mentioning who the builder is. Now, if they put their name all over the transmission or something, there's nothing I'm going to do about that. I'm not going to certainly paint over it or conceal it, but otherwise, I'm not going to reveal the name of the builder. Anyway, that is the 5 fundamentals when it comes to part selection. So let's talk about hard parts. I'm going to start with the pump, and then we'll kind of work our way down the bench, and then I'll conclude with a discussion about Jake's Performance's recalibration kit. Okay, I want to have a discussion on the pump, because the pump is so foundational with these transmissions, and you have to care for all aspects of the pump, and that starts with a inspection upon teardown. So this is the pump that came out of here, and I went over this in detail in my teardown video, but I'll show it here as well. So this thing had an extremely worn crescent here on the leading edge, and it was primarily due to the fact that this bushing, while it was replaced, I mean, this is not the correct bushing for this vintage of pump. This is an early pump. The unit is a 94 unit. This is a late model bushing. Okay, so this bore in here for the late model pumps, the bodies anyway, changed, and so it necessitated a different bushing, but I'm not sure why the builder installed this bushing. Maybe that's all he had on hand, who knows. The other thing he didn't do was drill out the drain back 1/4 of an inch. So stock or mild performance or heavy duty towing, hauling 480Es, you don't really need to do that, but for anything real high RPM and performance, I strongly recommend it. So what had happened here was that the torque converter and the bushing had so much spacing between them, so much clearance, because this bushing was so worn out, that it was starting to kind of side load the bushing on this one side. I mean, you can tell this bushing is asymmetrically worn. I mean, you're going all the way into the Babbitt core here, whereas on this side, you have almost no wear at all. So that was basically forcing the drive gear hard against the priming crescent, force thrusting it, if you will. Okay, force thrusting, yeah, tongue tied. So that basically destroyed this pump body. Now you can remachine this. You put it on a vertical mill, you mill out the pocket, you cut the crescent, and then you face the deck surface, and that will give you a brand new pump body where you can install a set of oversized gears. We're not going to do that. We're going to install a brand new pump body. This one's actually at 97 and up, and how you can tell is just look at this area right here at the roughly 12 o'clock position on the crescent, with the crescent facing upside down, And the 97 and ups all have this partition in this otherwise large rectangular area, where your 91 to 96 bodies do not have that. Okay, you can retro back a 97 and up body on a 91 through 96 stator support assembly, but you cannot prospectively install a 91-96 body onto a 97 and up stator support assembly. You just cannot do it. Okay, so with that said, we have a new bushing installed. We also drilled out the drain back to 1/4 of an inch. Yeah, I don't know if you could see this, but it's in there somewhere. But that's the the other side of it. One thing that you want to try and avoid doing is nicking too badly the opposing wall here when you punch through. What you can do if you want is stick something down in here like a piece of wood, a small piece of wood, and when the drill bit punches through, it'll go into the wood instead of the side of the casting wall. And you could do that for anything you're drilling. Just stick like a wooden dowel if you're doing another lube mod, say on the overdrive drum there. I'll show you that in a minute. I stick like a piece of wood so that when I punch through the casting, I don't actually go into the other side of it, and nick it up or something. All right. Next thing I'll talk about with respect to the pump is the clearances. So you always want to check your clearances. So just take your gears and install them. And then what I like to manage too with these is anywhere from, I want to say 8/10 thousandths to 2 thousandths between the face of the gears and the deck surface, and then anywhere from like 2.5 to 3 thou between the inner diameter of the pocket and the outer diameter of the driven gear. So you can use micrometers for this. That's the more accurate way to do it, or more precise, I should say. Or you can use a straight edge and a set of feeler gauges. So I have a 1 thou, a 2 thou, and a 3 thou feeler gauge here. That's what you see. I know you're not going to be able to see the actual numbers, but trust me, that's what they are. So first thing you want to do is just simply rotate your gear set. Make sure that as you're rotating, you're not coming into kind of hard contact with your straight edge, because if you are, then there's no need to measure. You're out of spec. You're too proud with the gears relative to the deck. Okay, so then from there you could take a 1 thou feeler gauge and see if you can slide it underneath. So it's real tight. As you can see, I'm moving this, moving the straight edge when I'm trying to do it. And I'm doing this haphazardly, to be honest, just for the sake of video. But when I was doing it independently, the 1 thou feeler gauge would slide underneath. But, oh, you know what? I'm sorry, I'm using the 3 thou feeler gauge. My bad. Let's try the 1 thou feeler gauge. There we go. I was going to say, when I was doing this, it wasn't this bad. It wasn't dragging that much. So it's sliding in between the straight edge and the gears. I'm experiencing a ever so slight bit of drag, but it's not anything that concerns me. And here I'm getting stopped because I'm coming into hard contact between the crescent and the deck surface here on the end of the gauge. So this is 2 thousandths. We'll try it. And as you can see, I'm coming into contact halfway through. It's not going to let me pass. Okay. And then here's the 3 thou gauge. So what I'm going to do is I'll take the straight edge off. Let's come over here and we'll see if we can fit this in here. If you can't, you want to make sure that at least a 2 thou gauge will fit, but the 3 thou gauge fits just fine, and it feels perfect. Because like I said, this is really a hasty check. Micrometers, inside, outside, and depth micrometers are going to be your better bet if you're wanting the absolute highest or best precision with your clearance measurements. Okay, last thing I want to talk about when it comes to the pump is this wear plate. So you can buy the wear plate from Jake's Performance. I think they're like 70 bucks or something like that on his website. They're 56 thousandths thick. At least that's what I measured this one to be. It's got a little paint on it. So the one thing you need to be mindful of when installing the wear plate, and goes just like this on the body, is that this will dimensionally change the overall depth of the pump, and more importantly, the relationship that the pump has between it, the converter, the bell housing, and the flex plate bolted to the crank on the engine. So converter spacing is absolutely critical on any transmission, and when you put a wear plate, you will have an additional, thickness corresponding to the wear plate that will move this pump structurally closer to the flex plate. So that means the converter is going to have a little bit less spacing between it and the flex plate. So Jake's provides you detailed instructions if you're using his wear plate on installing and checking for this, and he will tell you what spacing you need. I'll annotate the video in terms of what that spacing is so you have it, and I'll link his instructions in the description. But the bottom line is, if you're going to install the wear plate, and I don't work for Jake. I don't, I don't benefit from people buying his stuff, but, and I say that because what I'm about to say, it might sound like I am, but if you're going to buy his wear plate, it might be a good idea to buy his converters as well. And that's because he makes them with respect to the wear plate, and it's understood, since, he's sourcing and creating both parts, he knows what spacing you need to manage to, and you have a system that will work. So that's my suggestion. Otherwise, he will give you guidance or tech support if you need it to understand what kind of converter that you need to have, so that you don't have too tight a fit between transmission, converter, and flex plate. All right, bushings have been replaced pretty much on all these parts, so that's why you don't see a bushing kit. I've already installed them, including the stator. And when it comes to lube mods, you want to drill a 1/8 hole in this location. This will lube your overdrive roller clutch. Okay, this and the corresponding passage in the overdrive drum will allow more lube oil to pass to that roller assembly. If the one-way assembly in the overdrive roller fails on you, you will not have any movement in any range or gear. It's on in pretty much all range positions in reverse and drive. All right, as I mentioned before, billet input shaft. I like to install these anytime power levels get in that 7 to 750 range. I would say it's optional for anything less than that. The stock piece is pretty stout, but you're making 700 plus horsepower, I would just go ahead and put a billet input shaft in. It's good insurance. It's cheap insurance relative to what will happen if the factory piece fails during a race or something. The other things you want to consider, especially if you're going beyond, like say 850, 900 horse, is you're going to need billet pretty much everywhere in the transmission. You're going to want a billet or SFI approved flex plate, a billet converter, a transmission blanket, and or reinforced tunnel, because if the transmission flies apart because of some a drum just catastrophically comes loose and disintegrates, then that literally could be your life. So I know that like everybody wants to go fast and race, but you want to make sure that you also keep an eye on safety. So that's my plug there for that aspect of high performance transmissions. All right, so let's further talk about more hard parts, starting with the low reverse servo. I've been installing these Sonex billet servos over the course of the past, year or two, in all TH400s and 480Es that are intended for performance applications where engine power is in excess of 500 horse. And honestly, they're so cheap that I would just install them in every build, to be perfectly frank with you. They're only like $65 or $70 for the early style, and then I think another $10 for the 96 and up versions. So again, cheap insurance, and if you're doing burnouts in manual low, You want to stay in manual low when you do your burnout. Having a billet piston there instead of the factory piston is, again, another area where you're protecting yourself against catastrophic failure. All right, when it comes to end play in the transmission, okay, your travel, you're actually going to measure travel in 4 different areas. You're going to measure gear train travel. You're going to measure travel or spacing between the reaction and output carrier, aka front and rear planet. You're also going to measure travel or spacing between the 2 drums, the forward and the direct drum. And then you're going to measure your front end play. So I have shims here on the bench. These shims are made by Sonics, and these shims are for TH350 pump bearings to work with the TH350 pump bearing that you're going to use at the back of the case to rollerize it. And I mean, you should never not rollerize a TH400 or 4L80E in the rear, regardless of what your application is. I mean, a pump bearing from a TH350, I think they started putting them in 76 or 77 in those units. One of those plus a shim kit is like $10. And what you're going to do is you're going to take the 3-tab steel selective washer and this 4-tab Babbitt washer that goes on the output carrier or rear planet, and you're going to measure their thickness. I'm sorry, not the rear planet, the output shaft. I apologize, the output shaft. I'll talk about what you're going to do with this with respect to the rear planet in a second, but this will go on the output shaft from the factory. That's how it is. And the 3-tab steel thrust washer will thrust against this and be positioned in the back of the case. You're going to measure the combined thickness of those 2 things. Then you're going to measure the combined thickness of your TH350 pump bearing and whatever shims you have available. And then you're going to try to get as close as you can in terms of thickness with the bearing and whatever shims as you have with the 2 thrust washers, and that's going to be your starting point. And then you're going to mix and match shims until you get a rear end play that measures between 6 and 10 thousandths. That's my target. I like 6 to 10 thousandths. Then what you're going to do is you're going to write that figure down. Then you're going to measure the amount of travel that exists between the overdrive carrier, overdrive planet assembly, and the input shaft between this snap ring. So the snap ring here that secures the input shaft to the carrier, it's going to have a little bit of play in it as well. You have to measure that, and for most of these transmissions it's between 26 and 28 thousandths of an inch. Okay, then when you install your pump, you have your selective thrust washer that goes on the back of the stator. You're going to measure that because you want to know how thick it is, and then you're going to measure your end play there with the rear section loaded. So take that overall number that you have in terms of total travel with the rear section loaded, subtract out the number you wrote down based on the amount of space that exists between this snap ring and that overdrive carrier, and that's going to be your net front end play. And your net front end play should be greater than your net rear end play. Your rear end play is going to be, let's just say 10 thousandths. Your front end play should be 15 or 16 thousandths, somewhere in there. Okay, give you an extra 5 thousandths. If your front end play is equivalent to or less than the rear end play after you've subtracted out that snap ring measurement, then you will have a bind in the case between all the components and the front and the rear of the case at times. And you do not want that. A bind will destroy hard parts and the transmission will fail. So just be mindful of that. My 4L80E videos go through the measurement process in detail, shows you how to set up the rear, set up the front, set up the spacing between the drums as well as the 2 carriers. And you can watch those videos if you want to see that done live, so to speak. Okay, in any high horsepower application where you're making more than about 450 or 500 horse, it's a good idea to install a billet rollerized forward clutch hub. So this is a Jake's Performance hub, I believe it is anyway. He rollerizes this portion here, this bearing. Okay, this is what kind of comes in contact and works in tandem with the direct drum. And then you have your bronze thrust washer from the factory that goes here. There is one billet overdrive hub, forward hub that sold where there's bearings on both sides, and it comes with a shim kit. And you can also use these shims as well to set that space in between the two drums, but I have this one, that's what I'm working with. That other one is available from Transparts Warehouse. I don't know who makes it. To be honest, I've used it a couple of times, and until I can find out who makes it and where it's made, I've not used it. I've not used it again. I typically will use the Sonics version, and on Jake's website for his Stage 2 kit, he has a picture of the Sonics forward clutch hub in in that picture as part of what he includes in that Stage 2 overhaul kit. All right. So here's the pump's stator thrust washer, and then this thrust washer is non-selective. It goes to the center support. For the intermediate clutch, I like to use a billet steel backing plate. Okay, the intermediate clutch is a high-speed clutch, and it's subjected to a lot of force when that clutch applies, especially at wide open throttle and very high horsepower applications. I get these at CK Performance. He sells them on the website, and in conversations with him, and he's done God knows how many 480s, TH400s, he says he frequently sees the factory piece break when power levels get into that like 500-600 horsepower regime, and racing is something that's frequently done. So again, this thing I want to say is like $130 or something like that, but to me it's cheap insurance against a catastrophic failure in that area. All right, so we talked about these three billet parts. Talked about the lube mods here and there. Let's talk about the direct drum. So you can use your late direct drum. The late direct drum is going to enable you run a bonded piston. But the main takeaway here for high horsepower is this little bleed hole. Alright, note the position and location of the bleed hole. It's drilled at 180 out from the factory bleed orifice or ball capsule, and it is just below the sealing surface for the perimeter seal location for your piston. Okay, so you want to drill this bleed hole each and every time you build a high performance unit that's going to see a lot of RPM, especially in first gear. This drum is spinning at God knows how many RPMs compared to engine rotation when you're driving in first gear before you shift to second gear. The other thing that you want to do for every single performance application and even heavy duty applications is internally dual feed the direct clutch. Okay, if you're building a transmission on the bench, do not purchase the Transgo HD2 kit or any other kit that simply dual feeds through their proprietary spacer plate. It's not necessary. So dual feeding is a very simple process, and I'm going to talk a lot more about the hydraulics when we get to the calibration kit in a few minutes, but as far as what you're going to do in the case, you're going to leave the center. For the center support, you can leave the second from the top sealing ring off. Okay, this will not be installed. You're only going to install 3 sealing rings, one here, and one here. You're going to leave this sealing ring off. Then for the direct drum, you're going to leave the center seal, the center lip seal that goes here, you're going to leave that out. That will allow the entirety of the underside of that piston to be used for apply fluid in third gear. Okay, it's normally that way in reverse. Reverse is dually fed as per the factory engineering, but the direct clutch is not in a factory setup. In fact, you're only using the domed portion or the inner portion of the piston in third gear in a factory configured 4L80E. So you want that entire underside of that piston used. You want to dramatically increase the volumetric capacity of that clutch and consequently its holding power when it comes to horsepower and torque. And that's, why you're doing it. All right. Forward drum. Always check your sealing surface here. your inner diameter, where the sealing rings on the input shaft go, they're the two smaller sealing rings. So here's the drum as it would be in the transmission, facing front, and the input shaft goes here, and then over time the input shaft sealing rings will cut grooves in the inner diameter. And so if you see that, the thing to do is either replace the drum and or repair it by boring this out and installing a ductile iron steel insert, and that will ensure that you will not have that problem. Okay, delayed engagements and drive, slipping and forward, I mean, they're almost invariably caused by issues related to that sealing ring grooves being cut into the inner diameter there. Okay, another thing you can do for, again, real super high horsepower, high performance applications is run a billet steel backing plate / direct clutch hub. You don't really need it for power levels that what we're working with, but again, that 850, 900 horsepower regime is where you got to start shelling out big bucks for billet shafts and other billet parts beyond what you see here. Okay, intermediate clutch. Give yourself between, I would say, 75 and 100 thousandths, maybe 110 thousandths for the clearance, because you don't want that clutch to drag when you're in first gear just before the shift. Sorry about that. So this thing came in, had some glazing on the clutches, signs of drag. The clearance was about 50 thousandths, so we're going to set it around, like I said, 85 to 90, maybe 100. You want to use a Chrysler A518 forward clutch snap ring, either the 75 or the 88 thousandths thick version. This one had the 106 thousandths thick version installed. Okay, this is a little bit too thick, from a clearance management perspective, but otherwise it's great because it's so thick. So, it's like you have to work with the trade space. Got to trade off a little bit of thickness there to get your clearance right, so that you're not dragging in first and kind of sucking horsepower out of the engine. Okay, high rate return springs in the forward and direct clutch is a good idea, especially for very, very, very high RPM, 7,000 and above. I would recommend pair the bleed hole in the direct drum with high rate return springs. I mean, you could do it at less horsepower than that, less RPM than that. So much apply fluids go into that clutch, you're not going to have a problem with it not applying because of high rate return springs. All right, I think I've said everything I want to say when it comes to hard parts. I know I've been talking a lot. Hopefully this has been of help to you, and is maybe clearing some things up or kind of enlightening you to things that you previously didn't know. Hopefully that's the case. If not, I guess I'm wasting my time. But the last thing I want to talk about before we adjourn is the Jake's Performance recalibration kit, because I want to cover a few key things that you need to know when installing that kit. All right, last thing I want to talk about before we adjourn is the Jake's Performance recalibration kit. So, a couple key things you need to know when using this kit. Number one, the heart of the kit is the spacer plate. The spacer plate is proprietary to Jake's, and it's not recommended that you install this kit piecemeal if you happen to have different parts and what have you. So you buy it as a complete kit that's available on his website, and it comes with the spacer plate, the block off plate, and then several other items that you need to fully install everything. So you have a full set of instructions. They're also available on the website for download if you want to review them in advance, and they come with the kit as well in hard copies. So the main thing you need to know with this kit that's kind of standout attribute is that it allows for a true dual feeding of the direct clutch. And so what do I mean by that? If you think about all of the procedures for dual feeding direct clutch in the TH400, 4LADE that you see out on the web or in print or wherever, they all have one thing in common, and that is to have you plug the high reverse feed passage in the case. So when I was tearing this transmission down, and once I got the valve body off and spacer plate and all that stuff out of the way, the first thing I looked for was a 3/8 of an inch cup plug or something like that in this location. I didn't see it, and I was kind of surprised. That's because I really wasn't familiar with Jake's kit prior to working on this transmission. I had always used other things before, and I've always followed the same procedure, and that's what I show in my other 480E videos. So for Jake's kit, you do not have to plug that high reverse feed passage. In fact, you need to leave it alone. All you're going to do is leave off the center seal on the drum, the second from the top sealing ring on the center support, leave that off, and then install this kit with this plate. Okay, you'll have your block off plate for your otherwise 2, 3, and 3, 4 accumulator stack. That's pretty standard. But the plate itself will allow you to route your hydraulic circuitry and send 2 discrete streams of apply fluid to the direct clutch when shifting from second to third. And like I said, that is not possible with, as far as I know, any other plate on the market. So the factory plate, the CK Performance plate, Transgo's plates, the one in their HD2 kit, along with their standard plate, you know, the factory replacement plate for these units, all require you to plug that high reverse feed. Except for the Transgo HD2 plate, that's designed to dual feed the direct clutch entirely through the plate. In other words, you leave all 4 sealing rings on, you leave the center seal in the drum, and you just use that plate in that kit. And that kit's fine, to be honest, if you're just looking to wake up the transmission while it's still in the vehicle and otherwise healthy. As long as you don't do that stupid pressure relief mod and, you know, that EPC relief mechanism, leave that off. Don't drill any holes in the valve body. You know, but follow the rest of their instructions and you'll be fine. You may or may not have cross leaks associated with the sandwich style plate, but, you know, I don't think that's as a concern as using the EPC relief. But I don't want to get off on a tangent, just wanted to make sure I threw that out there since we were talking about plates. But the Jake's plate allows you to run a true dual feed. Okay, the other attribute that's also interesting is that it also defeats the 1-2 accumulator. So it eliminates that entirely. And what he has you do is he has you leave off the sealing rings on the accumulator piston for second gear. So you would install it just like you would into your low reverse piston assembly and go ahead and put it back onto the case, but you will not be using the sealing rings on the accumulator piston, so leave those off. Alright, when it comes to check balls, here is the guidance that he provides, and if you want, you can do this independent of his kit. It's up to you. But you're going to install the following: the coast clutch check ball, this is number 1, the 4th clutch check ball overdrive, that's the number 10 check ball, the number 3 check ball for the coast band, and the number 4 check ball for your intermediate clutch. You're going to leave out the number 5 and 6 check ball for the 2 accumulators, the 2, 3, and 3, 4, as well as the number 9 check ball for reverse, and the number 8 check ball for direct. Okay, number 8 and number 9 are just simply timing agents. So basically what they do is they restrict the flow of fluid to the extent that allows for an appropriate amount of apply time mechanically for both direct and reverse, and that's part of the factory calibration, and it was engineered that way so that your shift, send, or engagement in the case of reverse is pleasant. Okay, for high performance, pleasant will become a liability because the engagement is too slow, especially with shifting in direct. It's just simply too slow, it's not fast enough, and you're going to have a lot of slippage, and ultimately, transmission will fail and have to come out. So this is the check ball configuration that Jake's calls for. You can use this configuration regardless of what hydraulic or corrective kit you're using or performance recal kit you're using. That's the only thing that you can do independent of his kit. Other than that, you want to follow all the instructions and install it in its entirety. Okay, don't otherwise try to install it piecemeal, or don't try to discreetly dual feed the direct clutch using the 2 independent streams without the use of his plate, unless you know how to modify the hydraulics in whatever spacer plate you do have. In other words, modifying the plate to facilitate this kind of independent, discrete, dual stream feeding of that clutch. So lastly, I want to touch on calibration itself for shift firmness. So when this transmission came in, it had 150 thousandths orifice here for the 1-2 feed. The converter stall speed here is 2500. This is way too much regardless of what else is going on with the transmission and what else we're doing. So I'm probably going to, this is not going to go back in, not this plate. I ordered another one from Jake's, and I'm probably going to calibrate that to about maybe 100 and you know, maybe 110. Third at 125 is fine. Fourth at 85 is fine for a 700 horsepower application. I spoke with the customer and he had no issues with the third gear or fourth gear shift. With the TCC orifice here, this is going to be for your converter clutch apply. You don't need to modify this in any way, shape, or form unless you're installing the Sonex TCC regulator valve with their heavy-duty spring, and then you actually need to peen that shut by, you know, something like 5 thousandths. I think the Sonex instructions call for 25 thousandths. Okay, for this hole right here, this is going to be EPC balance hole. This hole has to be present if you are installing a 91 to 92 valve body and you are using a 93 and up electronic pressure control solenoid, and that's the only one that's available for the 91 up to 2003 model year 4L80s. 04 and up, they went with a different EPC. I think Bosch is again the supplier. The connector is different, the harness is different, but the way the EPC functions is not different. It's the same. But if you're going to reuse the original Bosch 9192 vented EPC, which is generally not recommended because, well, again, it goes back to the fundamentals and you always replace your electronics. If you are going to replace it, or excuse me, if you are not going to replace it, then you don't have to do anything. But if you are, and you're running a spacer plate that does not have this hole here, you need to drill it so that you'll have the EPC, bleed off function. Those 4L80s also had the torque signal compensator valve. That was part of the EPC cleaning cycle that was programmed into those transmissions in 91, 92. The harness was different than the 93 and up. They changed all that in 93. They got rid of that. 94 is a standalone year for these units. It was the last year that you had, what do you call it, neutral safety switch somewhere else, not on the transmission. 95 and up, they started installing the manual lever position sensor that bolted to the outside of the case over the selector shaft. 1993 was the last year they had an output speed sensor for 4x4s. 94 and up, they did away with that. So again, kind of a standalone year. 95 and up, the valve body changed. So 91, 92 valve bodies are one vintage, 93, 94 are a second vintage, 95 and 96 are a third vintage. So I know I'm rambling here, but as things are coming to my mind, I want to make sure you're aware of it. If we're talking build strategy, this is stuff you need to know if you don't already. The 95 and up valve bodies, the bore plug diameter for the third and reverse check ball, and I think the low reverse check ball too, changed. Sonex makes bore plugs with O-rings on them, but they don't make them for the 91 to 94 valve bodies, just the 95 and up. So if you have leakage in the bore plugs and you have a 91 through 94 valve body, then you can either find a different factory bore plug, see if maybe that works. You can try sealing it up in some fashion, or if nothing works and you're just leaking there real bad and it's not holding much in the way of vacuum, you're going to have to find a different valve body. So anyway, like I said, I just want to throw that in there because as it comes to my mind, I'm thinking about it. One more thing that has just popped into my mind, this as it relates to the pumps. From 97 to 03 or 04, there were two different pumps in production because there were two different case designs. So I'll link in the description the page that Transgo has, and it spells out what those changes are and illustrations and all that, so that at least you're aware of it if you have to replace pumps. Particularly it's the pump cover that you have to worry about. The pump cover and the case. The pump body, 97 and up, they're all the same. You can put them on any year 4L80E pump cover, stator, assembly, doesn't matter. Alright guys, that's it. Not rambling. So thank you so much for watching. Greatly appreciate it. Hopefully this video helped you in your journey with the 4L80Es and to some extent the TH400s. If you have any questions, comments, please leave them below. If there's anything else you want me to cover, or if there's anything I majorly missed or omitted, that's going to be my new word, omissed. Go ahead and leave it in the comments section, and I will make sure to either supplement what you have said or provide some information in my reply. All right. Thanks again, guys. Talk to you soon. Hope forward to seeing you on the next one. And until then, have a great rest of your day or evening. Thanks again.